This video is brought to you by CuriosityStream. Sign up today at curiositystream.com/realscience to get both CuriosityStream and Nebula for just $11.59 for the entire year. In every ocean in the world, from coastal shorelines to the tropics to the poles, to the endless deep expanses, live the most widespread creature in the world after humans. Through the centuries, it's been given many names: blackfish, grampus, whale killer. And while the seas are full of creatures vying for their place on the food chain, the orca is unequivocally on top. Their Latin name, Orcinus orca, is derived from the name Orcus, god of the underworld and champion of death, an apt reference to their fierce hunting reputation. They are the ultimate apex predator of the ocean, hunting everything from fish to seals and sea lions to humpback whales and even great white sharks. And it's not just what they hunt, but how they do it that sets them apart from every other animal. In the case of great white sharks, orcas will chase them down in packs and ram into their sides. The blow stuns the shark, allowing the orca to flip the great white over and hold it upside down, which paralyzes and drowns it. And the orcas don't simply eat the shark either. They carefully extract and consume just the livers, with an almost surgical precision. Great whites are so terrified of orcas that if a shark escapes an encounter with an orca, the shark will immediately flee their hunting ground and stay away for up to a year. Packs of Antarctic orcas use the cunning tactic of working together to make waves to wash seals off floating ice. Other groups swim in circles around schools of fish, blowing bubbles while slapping their tails on the water to corral the fish to the surface, where they can be annihilated in mass. They have been seen to coordinate hunts between as many as 50 individuals, and are constantly innovating new, often terrifying hunting methods. Hunting strategies like this have entranced scientists for years because of their apparent military precision. How are orcas able to communicate and coordinate such complicated concepts? How do they come up with so many new ideas and implement them so effectively? While many of these answers are still being uncovered, research is starting to get inside the minds of orcas, revealing just how powerful the orca collective can be. Though often called killer whales, orcas are more specifically in the dolphin family, of which it is the largest member. Today, they are the apex predator of the sea, but their evolutionary story didn't always take place there. 50 million years ago, this land-dwelling, wolf-sized creature called the Pachycetus lived along the edges of a shallow ocean, where it ate fish and other small sea creatures. Over the next 8 million years, some of its lineage slowly ventured more and more to sea, exploiting more ocean resources and trading its legs for flippers. Remnants of today's whales' land-dwelling origins can be found in their front flippers, where there are arm, wrist, and finger bones, and in their vestigial pelvic bone, a bone which serves no purpose today, but is simply a leftover from when they had hind legs. Today, orcas are one of the most recognizable animals in the ocean, with their distinct black and white coloring and immense size. Males can reach over 9 meters long and weigh up to 10 metric tons, about the size and weight of a school bus. And they can propel their huge bodies through the water at a ridiculously fast clip. An orca's body is cylindrical and tapers at each end to form a hydrodynamic shape. This shape, along with the orca's size and strength, makes it the second fastest marine mammal, reaching speeds of up to 35 kilometers an hour. At times, they've been seen leaping 15 feet into the air, and you would not want to be their target. Their bite force exceeds 131 megapascals. For reference, a great white's bite force is estimated to be only 27.5 megapascals. Acting alone, their size, speed, and terrifying jaws would probably be enough to put them at the top of the food chain in the ocean. But they don't operate alone. Orcas almost always work together in deadly pods. The pod is a family unit based on the maternal group. A typical matriline consists of an older female or matriarch and her male and female descendants. These groups work together in sometimes perfect synchrony, with a precision that is hard for scientists to wrap their heads around. Likely, the basis for this teamwork is a refined and complex form of communication. We don't know yet exactly what they're saying, but researchers believe that their huge repertoire of sounds, calls, and whistles communicate complex messages to one another. In the 1970s, scientists started to record and analyze the numerous sounds orcas make beneath the waves, in an attempt to gain insight into their mysterious underwater language. First, they heard many clicks, called click trains. These are the sounds the whales use for echolocation, as they look for food sources and map their underwater environment with sound. To create a click train, the orca takes a breath, and pressure from streams of air bubbles move up the airway from the lungs. This causes two flaps called the phonic lips to slap together. The clicking vibrations are then transferred to their bulbous forehead, aptly called their melon. The melon is an organ made up of specialized fats that help sound propagate. The clicks are organized into a beam as it travels through the melon. The sound is then emitted outwards as a series of high-frequency clicks and spread through the water like a flashlight beam. Each click lasts less than 1 millisecond, with frequencies ranging from 20 to 60 kilohertz, and with levels recorded over 220 decibels. Decibels underwater are measured slightly differently than in air, making this seem extreme, but it is still insanely loud. If the sound waves hit an object, some sound waves bounce back to the whale in the form of an echo. Specialized fatty tissues in the jaw area pick up the sound, and auditory nerves conduct it to the middle ear and brain, where it creates a picture of the environment for the orca. Echolocation allows killer whales to detect fish at distances of up to 500 feet, much further away than they could see in the dark, murky water. They can even differentiate acoustic signatures of different swim bladders of different species of fish, to ensure they get their favorite kind. Killer whales in the North Pacific, for example, prefer to eat almost exclusively Chinook salmon, whose range exceeds 15,000 square miles. This huge area is occupied by hundreds of other species of fish, including 5 other species of salmon, whose populations are often far more abundant than the Chinook salmon. But yet, the orcas can pinpoint and hunt down just the fish they want. Their echolocation is astoundingly precise. Next, researchers focused in on a different sound the orcas were making: whistles. Whistles are high-pitched, show a high degree of directionality, and are highly modulated, and as a result, they don't carry far underwater. Whistles are narrow-band tones with no or few harmonic components, at frequencies typically between 1.5 and 18 kilohertz, and durations up to 12 seconds. They can even extend into the ultrasonic range, with frequencies ranging up to 75 kilohertz in some populations. And because they don't travel far in water, scientists realized that these are the sounds the whales make when they want to have close-range, private communication with their podmates, which likely helps them coordinate certain attacks in relative secrecy. And then there are the orca calls, as loud as jet engines, that echo over many miles in the ocean. These pulsed calls are the most common vocalization of killer whales. They show sudden and pattern shifts in frequency, based on the pulse repetition rate, which is usually between 0.25 and 2 kilohertz. And what's surprising is that these vocalizations are not genetically predetermined. They are learned. When a calf is born, its first vocalizations are loud, high-pitched screams that bear no resemblance to the adult's calls. But eventually, calves learn which calls to make and under what circumstances. Scientists, however, have not yet learned the exact meaning of the orca language, but know that it's important for coordinating hunts. When orcas are working together during a herring hunt, for example, The sound underwater is off the charts. There are clicks, whistles, calls, sometimes with harmonic tones and tons of undulation. Because of its learned nature and complexity, scientists believe that there is potential for communication of complex specific information in calls, a true language being spoken. Researchers are processing hundreds of hours of audio data from tagged animals in an attempt to correlate the sounds to certain behaviors, to understand how exactly they communicate their hunts. Using artificial intelligence, scientists hope to one day be able to literally translate whale language into ours, perhaps even allowing us to converse with another species. Recently, an AI was developed that can translate one human language to another without help from a Rosetta Stone or key. Taking this one step further to decipher whale language may not be that far-fetched. Researchers are already working on training their AI to identify call types, find possible subunits, and detect recurring communication patterns. This, correlated with observed behavioral patterns, may one day decode the orca's language. But beyond giving hunting signals, orca language serves another purpose. Language is the basis for every orcapod's group identity, an identity so solid that orcapods, in a sense, have cultures as rich and varied as our own. And it is this culture, this group identity, that sets them apart as the most effective predators in the ocean. Though many pods of orca often live in close proximity to each other, they can lead wildly different lives. A type of pod called resident pods live in relatively predictable locations, largely around coastlines, such as the well-studied northern and southern residents off the coast of British Columbia. These are the most common types of orca, and many pods of resident orcas can live near each other, not exactly living and working together, but on occasion interacting. These pods typically have an average of 14 members, but up to as many as 50, and they typically hunt fish. But then there's another type of orca, called transient orcas, that are far more rare. These elusive and mysterious whales occur sporadically in unpredictable locations, often staying submerged for much longer than residents, hugging the shore but staying out of sight. These renegade orcas travel huge distances over their lives, with some pods of transients known to travel between Alaska and California. Transient pods are much smaller, averaging around 3 members, and they typically hunt marine mammals like sea lions. Transient orcas do not interact with resident orcas. It was clear to researchers from the beginning that orcas opt to live in these groups. But just how distinct these pods were from one another wasn't revealed until the 1980s, when researchers, for the first time, began to listen more closely to the different orca conversations happening under the waves. And what they found was that each pod has its own collection of calls, referred to as their very own dialect. One group of resident orcas, for example, relied on calls that began with a low pulse rate burst, followed by a simultaneous narrowband tone, which begins at a frequency of 3 to 5 kHz and then increases to over 8 kHz. Another group of resident orcas uses a different type of call altogether, a low-frequency, gradually rising tone, followed by a lower-pitch pulse, which is then followed by a sudden shift to a high-frequency tone and ending with another low-pitched burst. Resident orcas can have dozens of identifiable calls like this, each completely unique to their specific pod. And the difference in calls between resident and transient orcas, even in the same area, gets even bigger. Transient whales, overall, are very quiet compared to the residents. When they are foraging, they're usually completely silent, not even using echolocation, which is heard in abundance in resident pods. But all transient orcas studied in the Pacific Northwest shared one type of distinct call, usually used while foraging, and even then they did so rarely. A long, quiet, low-frequency call. The different orca dialects often go unchanged within a pod for decades, indicating that they're likely an essential way to maintain group identity. And this group identity is the key to their unrivaled success. A cultural species behaves differently than a species where everything is determined genetically. With each orca dialect comes a suite of wildly varied behaviors from group to group, each with particular traditions that allow them to carve out a specialized niche, hunting a particular target with a sophisticated, sometimes terrifying strategy. The killer whales off the coast of Argentina have, perhaps, the most startling tradition of all. It was first observed in 1985, and scientists could almost not believe what they were seeing. When the tide is high and the sea is calm, the orcas snag sea lions directly from the shore by intentionally beaching themselves. Like a terrifying tsunami, the orca surfs on an advancing wave until it's close enough to grab the unsuspecting sea lion from the tumultuous surf zone. Sea lions are notoriously clumsy on land, and during the transition from swimming to walking in shallow and turbulent water. So by the time they notice death itself approaching, it's usually too late to get away. Once grounded, the whale arches its body with its head and tail lifted and rocks sideways. This motion orients it parallel to the beach, and a subsequent wave helps to lift it off the bottom. The whale can then swim back into deeper water, carrying the prey in its mouth, where it will eat it or share it with its pod. This intentional beaching technique is a tricky maneuver. It's not easy for the orcas to synchronize their movements with the waves coming in and then back out. And if they miscalculate, they risk getting actually stuck, which can prove to be deadly. There are 30 orcas that live along this stretch of coastline, but only 13 orcas have mastered the stranding technique. To get to this level of mastery, they have gone through years of rigorous teaching and training. Young orcas can be seen with older adults practicing again and again, beaching themselves repeatedly, but not yet trying to catch any prey. Sometimes the older orca introduces a prop, like seaweed, to enrich the training. It's always females who teach the young orcas, and they do so with remarkable care and patience. Some young whales never make it through the training. The feeling of going aground and the feeling of their entire body weight out of the water freaks them out enough to never try again. Only a few ever get the hang of it. The young orca's first attempt to catch live seals might not happen for years, and when it does, they still need the assistance of an adult to return to the water with their prey. This shows that learning hunting techniques needs a high degree of skill and requires high parental investment to reduce the associated risk. And though difficult, time-consuming, and dangerous, social transfer of skills like this through apprenticeship is one of the key reasons orcas are so highly adaptable, and thus such formidable predators throughout the entire world. The culture in groups of orcas is so profound that scientists even believe that orcas are the only non-human organism whose evolution is driven by it. Just as some humans have evolved to tolerate lactose, for example, as cow milk became increasingly introduced to our diets, orcas too are evolving due to their choices and traditions. Transient orcas are even so distinct from resident orcas that scientists believe it's a matter of time until they become their own species. Not because geography separated them, but because culture did. But there's one more key ingredient, without which none of the orca's complex culture would be possible: the orca's giant brain and incredible intelligence. Orcas have the second biggest brain in the animal kingdom after sperm whales. It weighs in at a whopping 5.4 to 6.8 kilograms. But exactly how brain size translates to intelligence is not straightforward. Scientists have found that while absolute size is important, its size relative to the body is more so. The larger the brain is relative to the body, the more brain weight might be available for more complex cognitive tasks. One measure, called the encephalization quotient, or EQ, tries to measure this ratio, and is used to convey how small or large a species' brain is compared to other species with a similar body size. And orcas are near the top of the list. Humans have the largest, with an EQ of about 7. Bottlenose dolphins are next, with an EQ of around 4. And next are the orcas, at about 2.5. But beyond this impressive brain-to-body ratio, compared to other mammalian brains, the orca brain is, in many respects, highly unusual, because it has extremely pronounced wrinkling and folding in the cerebral cortex. This wrinkling is called gyrification. Gyrification increases the amount of total cortical nerve tissue that processes information, making brains with more wrinkles and folds able to handle more data and process it faster. Cetaceans, the toothed whales and dolphins, have significantly higher gyrification compared to land mammals. The gyroencephaly index for humans is 2.2. For bottlenose dolphins, it's 5.6, and for orcas, it's 5.7, the most gyrified brain in the world. Yet perhaps the most fascinating structure in an orca's brain is its extremely developed insular cortex. The insula is involved in consciousness and the regulation of emotions, like compassion, empathy, interpersonal experience, and self-awareness. This means the orca may be emotionally intelligent in the same way we are, aware of the feelings of others, and aware of its own existence. And this may be the ultimate measure of consciousness in the animal kingdom. In 2001, researchers put orcas to the test, a test to gauge if orcas do indeed have a sense of self, by determining whether they can recognize their own reflection in a mirror as an image of itself. This was done surreptitiously by marking the black part of its rostrum with white ointment and the white part with a dark green ointment, and observing whether the animal reacts in a manner consistent with it being aware that the dye is located on its own body. Such behavior might include turning and adjusting the body in order to better view the marking in the mirror. And the orcas in the study not only noticed the markings, but seemed to be completely fixated on them. They had spent time in front of mirrors before, but with the markings seemed to not be able to look away. They blew bubbles at their reflection, bobbed their head, and stuck their tongue out. And all these behaviors were unusually frequent and lasted longer than at any time before the markings were placed. While this is not necessarily a sign of consciousness as we know it, it is not unreasonable to think that the orca mind works a lot like ours, and that they are capable of high-level thinking and feeling, and can perceive the vast complexity of the world they live in. A highly intelligent, dominant social species, where the young are taught difficult lessons over many years, and where family takes care of each other, it's hard to not see a reflection of ourselves in them. Even though we diverged from the orcas many millions of years ago, they may be our closest counterpart in the way we both experience this world. The more we observe the orca world, the more the incredible complexity of their lives becomes clear to us. And at every turn, researchers seem to be discovering an orca behavior even more mind-blowing than the last. Recently, another orca behavior started to be revealed, and was also caught on film. Orcas are notorious for working together with other orcas. But now they've been caught on camera not just working with their own pods, but with a completely different species, the humpback whale. What is sometimes their prey, humpback whales are now acting as their partner in some areas, as they help each other in hunting shoals of herring. It's a behavior that has to be seen to be believed. And to see it in action, you should watch the Orcas vs. Humpback episode of Sea Hunters on CuriosityStream. This is a brand new 6-part series that covers unexpected survival techniques of the ocean's predators, with some of the most groundbreaking footage of these behaviors that's ever been captured. Other episodes include the unexpected conflict between sea lions and hyenas, and the cooperation between dolphins and gannets, and detailed coverage of the orca stranding method as they snatch sea lions from the shore. This is one of many incredible series on CuriosityStream. Alone, CuriosityStream is a fantastic educational streaming platform. But now, CuriosityStream has partnered with us to offer an even better package. By signing up to CuriosityStream, you now also get a subscription to Nebula. Nebula is a streaming platform made by me and several other educational YouTube content creators. It's a place where we can upload our content ad-free, and a place where we can experiment with new original videos. We have so much new exclusive content planned for Nebula in the new year, like a Real Science series on human evolution, and Real Engineering's new series, The Battle of Britain. And right now, the bundle deal is at a hugely discounted holiday price. For just $11.59, you get access to both CuriosityStream and Nebula for the entire year. That's 42% off the usual price, and means you're getting both services for less than $1 per month. It could be a great last-minute Christmas gift for your friends and family that you don't have to stand in line at the post office for an hour to ship. Signing up is also the single best way you can support this channel. It helps us to keep growing and helps us to bring you more and more new content. So go to curiositystream.com/realscience to get in on this incredible deal. And if you're looking for something else to watch right now, you can watch our previous video about the complex reality of lab-grown meat, or watch Real Engineering's latest video about the insane engineering of the James Webb Telescope.